Human exposure to hazardous metals primarily occurs through food consumption, a concern escalating among Filipinos, especially Marinduque residents.
In particular, the said province's geological characteristics and copper mining legacy have led to the accumulation of heavy metals in their environment, resulting in the deposition of mine tailings into the soil.
With that, a group of researchers from Mapua University conducted an extensive study about the levels and trends of metal concentrations in soil and vegetables from the 6 municipalities of Marinduque.
Vegetable and soil samples were collected from 6 Marinduque towns, as shown in this list. 4 vegetable types such as string beans, sweet potato tops, bitter melon, and eggplant were sourced from public markets and farmyards in each town, resulting in 96 triplicate samples. Also, composite soil samples were taken from each municipality at depths of 0 to 30 centimeters.
With these samples, metal concentrations, specifically cadmium, chromium, copper, iron, lead, manganese, nickel, and zinc, were triplicately measured using ICP-OES Perkin-Elmer Optima 8000. Subsequently, the soil pollution, soil effects, health risks from metal consumption, and the metal-soil-vegetable relationships were assessed by different parameters shown on this slide.
The key findings of the study found out that most soil metal concentrations, except cadmium, surpassed the soil quality standard. The p-value value for all soil samples also consistently indicated high pollution potential. These outcomes indicate elevated metal levels beyond acceptable limits. It was also found out that the majority of metal levels in vegetables surpassed the maximum permissible limit, highlighting the potential health risks with their consumption. Lastly, it was found out that the metal levels in soil and nearby vegetables were often similar, suggesting they might be related. This could mean that there is the potential uptake of pollutants from the soil by vegetables.
Now, to uncover the chemistry behind this study, we will look at inductively coupled plasma optical emission spectrometry. ICP-OES is a scientific technique used for quantifying specific elements within a sample. This technique operates on the principle that atoms and ions possesses the capability to absorb energy, prompting the movement of electrons from their base state to an excited state. By subjecting the samples to inductively coupled plasma optical emission spectrometry, the study was able to measure the emissions of light and characteristic wavelengths, effectively identifying and quantifying various metals of interest.
In conclusion, metal pollution in soil is a serious environmental hazard, particularly in areas where soils intended for agricultural practices are near the sources of pollution. This adversely impacts plants, microbes, wildlife, and human health through ingestion, inhalation, or skin contact. Overall, this study can be used as a reference for the development of more studies for more specific contaminants and edible agricultural yields aiming to protect public health.
This had been Group 4 of N02A, and we trust that you gained insights from our presentation. Until our next talk, goodbye!